Okay, here we go. This is Algebra 2, New York State Algebra 2 with trigonometry. This unit is Unit 4. It's our polynomials unit. This is day 1 of Unit 4, where we just discuss graphing different polynomials of different degrees, odd functions, even functions, what's the end behavior, what are the limits as you approach certain infinities and negative infinities and things like that. Shouldn't be too long of a video. Stay with me. Pay attention. Hopefully you'll learn a few things. If you have any questions, feel free to shoot me an email. If you like what you see, don't forget to subscribe. Can never hurt to subscribe. Make me feel good. All right, here we go. Simple. Here we go. Hopefully. All right, so this first function, it's an odd function. Its degree is 1, even though you know I don't have to put a 1 there. The degree is 1. So the degree, what I really want you to focus in on is the degree is odd. Okay, odd behavior means that it's going to go up in one direction and down in another direction. Whether it be a cubic, a 5th degree polynomial, a 7th degree polynomial, it'll go up in one direction and down in another. Now, whether or not it goes in this direction or it goes up this way and down this way, well, that's to be determined. We're going to talk about that. The next thing we're going to look at is this thing right here. Now, I know you know that's the slope. You've been dealing with this a long time, but it's also the leading coefficient. So I'm going to call it the LC, the leading coefficient. And in this case, the leading coefficient, and again, I want you just to concentrate on whether or not it's positive or negative. Now, I know you've graphed these things a million times. I know you know the y-intercept is 1, or excuse me, -1, and the slope is positive 2. So, you know, this shouldn't be any problem graphing. Okay? But today we're just going to sketch. So this might be the only one I actually physically graph. Well, that's not true. I'm going to take out the TI Nspire, give you a little introduction with the TI Nspire. But you know, this is a graph of a linear function. It is an odd function, so it's going to approach this way, and it's going to go down forever and ever in this direction. And that's what odd functions do. They go up forever and ever, and they go down forever and ever. So exciting! Oh my gosh! Okay, not really, but let's keep going. Maybe you'll learn a few things from me today. This function is an even function. Now, I know you've graphed a few of these. This is a simple parabolic curve. Again, what we're going to look at is its degree, and in this case, and again, when we're looking for degree, what we're looking for is the highest exponent. Now, if it's written in standard form, the degree should go down. Like, for example, this term has a degree of 2, this term has a degree of 1, and this term has a degree of 0, so that's in standard form. And we're looking for the highest degree. In this case, we're just looking to see whether or not it's even or odd. Then we're also going to look at, and we want to talk about the fact that it's even. And we're also going to look at the leading coefficient, and what we're concerned about that is whether or not it's positive or negative. In this case, it's positive. Now, I know, again, if I was just sketching this, I would probably just draw a quick, simple parabola. It's even. Even polynomials go up in both directions. Now, whether or not they both go both up or both down is what we're going to discuss today as I go and work through these problems. Now, just to give you a little heads up on some graphing calculator work, we'll also type this in there. For those of you who haven't used this calculator in a while, going to the main screen is the easiest way. Lots of different options here. We're just going to graph. I'm not going to go through this. Eventually, I'm going to do some tutorials on calculators, but not today. Today, I'm going to assume that you can follow my directions. Pause it if you need to. I can't slow down the way I talk. This is just the way I talk. I talk really fast. Can you hear me now? Okay. We're going to hit this parabola right here. That stands for graphing. It gives us function notation. We'll simply type this in. 2x squared plus 2x minus 1. All right, and that's what this parabola looks like. So if I was to take this over, for those of you who would like to look at the table, the easiest way to get to the table is simply to hit Control and T. Get you to the table. Most of the time, your teachers want you to write down all the points or values that it can work. So it looks like it was -3 was the smallest, I believe. -3, -2, -1, 0, 1, 2, 3. Maybe that's about as far as we go. And I know this was 11, but I don't remember where the other ones were. 3, -1, 3, -1. Where was that calculator? I don't know why that popped up. 3, -1. Oh, it should be 0, -1. Oh, wait. I think it was also -1, -1. Yeah. -1, another -1, 3, and 11. That's about all I can graph. So, again, I told you we're not going to get a lot into graphing today. In this case, it looks like I'm missing the vertex. That would be, it looks like probably between 0 and -1, probably a -0.5 something. So let's see, -311. -311 would be off there. Normally you don't want to graph points off the grid, but this is not too far. We'll be okay. -2, 3, -1, 1, 0, -1, 1, 3, and then 2, 11. It just gives me an idea where to shoot for. Now, I'm going to guess the vertex is probably somewhere around there. What I want you to get from what I'm talking about today, and I think after this one, I'll do the cubic on the graphing calculator too, just to give you an idea what that looks like on the graphing calculator. But then after that, I'm just going to give a quick sketch of what these things look like. And just based on whether or not it's even or odd, and whether or not the leading coefficient is positive or negative. All right. Now in this case, since this is a even exponent, I knew it was going to go off in both directions, and the fact that the leading coefficient was positive meant that in both directions it would be going up in both. And what I mean by in both directions, as x approaches positive infinity or as x approaches negative infinity, the y value is going up in both times. All right, let's take a look at the next one. This one's odd. So if you remember correctly, just from a couple problems ago, first of all, I know it's odd because the highest degree is 3. So the degree is 3. And my leading coefficient, again, is positive. Now, I just had something like this. Leading coefficient is positive, and it's odd. That means it's going to be going either up and down, off the screen, off the grid, off your coordinate axes, going up or down because it's odd. Now, whether or not it does this again, or it does this, that's what we're going to talk about over the next couple of problems. But in this case, we're going to use the graphing calculator. And again, this will be the last one I use the graphing calculator for. Let's get out of this. We'll just go get a fresh graph. I like having a fresh graph. Usually you don't have other people's garbage in there. And we'll get all this typed in here. X cubed. Now with a cube, you're not going to get too many points. Plus 2x squared plus 2x minus 1. All right, and if I graph that, that's what the basic cubic function looks like right there. It's not your toolkit function. We've talked about the toolkit function. It's not your toolkit function. This is just your basic cubic function. It's got a curve, and it goes up in one direction and down in the other because it's odd. All right, so let's go look at the table. We're not going to get too many values because it is cubic. When you cube numbers, they get really big really fast. All right, so -3, -16. I'm just going to write that over here. X, nice Y. -3, 16. -2, -1, 0, 1. I don't think we can get any more points than that. -5, -2, -1. -5, -2, -1. I think maybe one more. 1, 4. 1, 4. So if I plot these, -3, -16, now that's way down here. That's really not a point I can graph on this thing very accurately. -2, -5, that's here. -1, oh, I just graphed that in the wrong place. Oh, it's so embarrassing. Let me get rid of that thing. -2, -5 is right there. -1, -2 is right there. 0, -1 is right there. 1, 4 is right. That's 3, right? There's 4. So it's going to look something like this. A little squiggle in it and going off in that direction. What I want you guys to understand, though, is if it's odd, see, I don't know why those don't pop up. Oh, that's better. If it's an odd function, it's going to go up and down. If it's positive, then it's going to go up, going to the right, and down, go to the next. Now, what I like to tell my students is, think about if you were graphing a positive sloped line. Wouldn't a positive sloped line look like this? That would have a positive slope, right? Well, if I graph between these two arrows, and I know it's steep, but doesn't that have a positive slope? So when I have a leading coefficient that's positive, it's going to go up just like a normal line would, have a positive slope. Again, if that leading coefficient is negative, then that curved function is going to come down. All right, so let's talk about this. I have a degree. We're going to talk about the degree. I have a degree that's positive, even. And I have a leading coefficient that's negative. And again, I'm just sketching this. I mean, the fact that I know that it goes to this point, that's kind of cool. That's about all I know really right now. But it's negative, but it's even. So even means it's either going to go down in both directions or up in both directions. If it goes up, that means the leading coefficient is positive. If it goes down in both directions, that means the leading coefficient is negative. Well, since my leading coefficient in this problem is negative, that means it's going to be coming down. So quick sketch, and that's all I need to look for. This next one, it's the degree is odd, and my leading coefficient is negative. Well, that means it's going to have a general shape downwards, like a negatively sloped line. So I just going to go and give it a little bend and a little curve, because the cubic function bends and curves like that. Not a great accurate graph. I almost did hit the y-intercept here. Remember, this thing right here is the y-intercept. But that's generally the shape of this thing. All right, here we go. And that's all I want you to get out of this. Oh, you know, I tried to throw you off here. I put a fraction. It's no big deal. It's an even function. That means they're both going to go up or both going to go down. So, excuse me, the degree is even. My leading coefficient, I don't care that it's a fraction. I don't care if it's a fraction. What I care about is whether or not it's positive or negative. In this case, it's negative. And since my y-intercept is 4, I'll just do this. And, you know, I could draw this thing any way I want. Now, this is a 4th degree function. It might do something funky like that. As a matter of fact, let's take a look to see what this thing looks like. Because this is, nah, let's not. I think it's going to look something like that. You can grab the calculator and do that. I think it's going to look something like that. 4th degree of functions. Just have a couple double squiggles in there. Usually, depending on if they're, you know, if you're missing all this stuff, it won't have too many squiggles. It almost looks like a parabola then. All right, there we go with that. Do I have any more? Oh, now I have a degree is positive. Excuse me, the degree is even. And my leading coefficient in this case is positive. So again, it's a 4th degree function. Kind of look like this, something like a W. They're both going up because it's positive. This is an even function again. So my degree is even. My leading coefficient in this case is negative. And that just means, I mean, it could just look simple as that. That's not what this is going to look like. I'm just trying to get you an idea of what the end behavior is. I know that you can graph a graphing calculator, plot a few points, and get them. In this case, we're looking to see what is the end behavior. All right, so my leading coefficient here is even, and my degree, I'm not sure why I did that second, is odd. Well, degree odd, again, is going to go up in one direction, down in the other. And if it's even, excuse me, why did I do that? This is what lots of kids get confused with. So I'm glad I kind of made that mistake. Leading coefficient, I don't care whether it's even or odd. It makes no difference. What I want to know is if it's positive or negative. And in this case, it's positive. Positive means it's going to go up to the right, down to the left, just like a positive sloped line. And remember, a line is also an odd function. So put a little bend in it, and there it is. And again, if I were to grab my red pen and just draw a dotted line in between those two things, wouldn't that line, okay, that's a line. Wouldn't that line have a positive slope? I know what you're thinking. Absolutely. Okay, you're probably thinking, when is this video going to end? It's not going to end. It's going to keep going. Oh my gosh, all this work we got to do. Okay. Let's see. Let's see if I can get this one without any mistakes. The degree is odd. That means it's going to go up or down, up or down this way. The leading coefficient is negative. Well, since it's negative, it's going to look like a negatively sloped line. That means it's going to be coming down as I go this way. And I'll put a little bend and curve in it. There's my 3rd degree. Oh, this is a 5th degree function. It's going to have maybe a few more bends and curves in it, but it's going to generally have that shape where it goes off into this direction and off into the direction. That's called the end behavior. All right. So again, let's draw a quick sketch of what the positive, again, this is the leading coefficient, and this is the degree, what it's going to do. Positive odd. Let me draw some axes in here, and I'll grab some different color just to be really festive. Those are some sick. I'll grab blue. Positive odd. It's going to go up in both directions. Now, how you connect those dots, that depends on what the graph's going to look like, but it looks something like that. Point in that direction. Man, I should have been an art teacher, not math. And that's just some crazy, crazy, crazy good art skills there. Negative. Leading coefficient is negative. The degree is odd. Wait a second here. Wait a second here. Let's scratch that. Back up. Reverse. Kind of embarrassing. Gonna have to snip that out. I wonder if I can do that. I gotta check to see if I can do that. I think I can. I think I can. Wait a second. My leading coefficient is positive, but the degree is odd. If the degree is odd, it means it's gonna go up and down, or up and down. Being positive means it's gonna go up and down like this. Since it's odd here, my degree is odd here, and my leading coefficient is negative here, it's going to go like this. All right. I got to stop getting behind myself. Got a little bored. Got a little lackadaisical. All right. Positive leading coefficient. So my leading coefficient is positive, but it's even. And even means it's going to go up or down. In this case, up. In this case over here, since it's negative, we're both going down. All right. I think I got it now. Boom, boom. There we go. I'm going to use this as an opportunity in YouTube to throw some kind of like text on the screen if possible. Otherwise, I'll try to delete this thing out of here. Hopefully, I didn't screw up your graphs notes too much. But you know what? Pause it. Grab the other end of your pencil. Erase it. And right over again. And then you can come into school on Monday and call me an idiot. Hurt my feelings. Okay. So here's what whenever you get a simple question that says, okay, well, describe the end behavior. Quickly, boom, draw some axes. Then grab your other colored pencil. No. And let's see. It's odd. That means it's going up and down. And it's negative. So it's going to have like a negatively sloped line. So it's going to look like this. Now, here's the part some of the kids don't understand, and hopefully you will. As x goes to the right in this direction, or as x approaches positive infinity, what is y doing? Well, y is going down, isn't it? So y is approaching negative infinity. As x is approaching negative infinity, going this direction, actually, x is going this direction, y is going this direction. As x is approaching negative infinity, y is approaching positive infinity. All right, over here we have another odd function. Even this, it's positive odd function. Positive odd function means it's going to go like this. And if I want to describe the end behavior here, as x approaches positive infinity, as x is going this direction, y is going to this direction. Y is approaching positive. Y is approaching positive infinity. And down here, as x goes in this direction, or as x approaches negative infinity out this direction, y is approaching negative infinity. So as x approaches negative infinity, so does y. Y also approaches negative infinity. Awesome stuff, Kraus. Whew. All right, quick axes. Even. That means they're both going to go up or they're both going to go down. Because it's negative, they're both going down. So I draw a quick sketch. Okay, I said I know this thing is both going down. I don't know exactly what it looks like. But again, we're only interested in the end behavior. So as x goes this direction, do you see y going in this direction? So as x approaches infinity, y approaches negative infinity. As x goes towards negative infinity, isn't also y going towards negative infinity? So as x approaches negative infinity, y also is approaching negative infinity. All right, over here, we are even So we have an even exponent, and we have a positive leading coefficient. So let's see, even means it's going to go up, or both down. In this case, since it's positive, they're both going up. So as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity, positive infinity. Both of these, actually, that's one of the things I wanted to talk about. When we're talking about even, both these things here, the y values will be the same. Again, because as it approaches to the left or the right, as you're going out towards the positive and negative infinity, it's either both going to go up or both going to go down. YMCA. Yeah. I feel like I'm in a wedding. All right, let's see what we got here. Oh, man, come on. It's a line. Positive line. Boom, going up like this. So it's x, and it's an odd. Notice it's an odd, and it's positive. So as x approaches positive infinity, y approaches positive infinity. And do you need the positive? No, you don't need the positive. As you get a little older in pre-calc and things like that, I think sometimes they'll put those positives and negatives in there, but they'll explain what they're for. They're for something different. They're for something a little bit different. As x approaches negative infinity, so does y. Y approaches negative infinity. And our last one, the degree is even. It has a leading coefficient that's negative. So let's see. Even means they're both going in the same direction. Negative means they're both going down. And again, I could just simply draw a parabola, because that's really all an even exponent is. Again, it's a parabola going up or a parabola going down, depending on what the leading coefficient is. So as x approaches positive infinity, y approaches negative infinity. And again, the y ones are going to be the same, because no matter if I go to negative infinity or to positive infinity, the y values are both going down. So both going to approach negative infinity. All right, so last page here, real quick. All I want you to do is tell me whether or not the degree is even or odd on these. So let's see. It's going off in both directions. That means the degree is odd. And my leading coefficient. Now, wait a second. If I draw that line, doesn't that have a positive slope? So the leading coefficient should be positive. Both going in the same direction. That means that my degree has to be even. Since they're both going down, that means my leading coefficient, my degree has to be even, and my leading coefficient has to be negative. To left. Going in opposite directions, that means my degree has to be odd, and my leading coefficient has to be, I don't know how I'm going to get negative out of that, negative. Now again, if I draw this slope in, that's got like a negative slope to it, right? So it's a negative slope. And finally, we have a 2 going up because they're both going in the same direction. That means it's an even degree, and they're both going up, so that means positive. So hopefully from this little short, very quickly worded video, you understand a little bit about end behavior of different degreed polynomial functions. Again, real quick review. Even, with an even, both going in the same direction. Either up or down. This would be positive, this would be negative. With an odd function, odd like myself and some of my students, that means they're going in opposite directions. This would be positive because it kind of has a positive slope, and this one would be negative because it kind of has a negative slope. So this would be negative. Hope you enjoyed this. Hope it wasn't too much work for you. Enjoy the rest of your day. Again, if you like these videos, keep checking me out. There's going to be a lot more coming, and I should have some calculator stuff and some other things available. It's all stimulating stuff. It's mathematics. What else could you love but mathematics? Number one subject. Number one. Number one. Use this finger. If you use any other finger, it's the wrong answer. Peace out. Have a good day. Peace out. Makes me sound cool.